Thanks for the introduction, which means I can already skip to this slide. Half of it has already been said. I did start Inuit 15 years ago. I used to be a developer ages ago, then I ended up being an operations person. The latest addition to this slide is that we spun off a new consultancy, a new company focusing on observability and mostly on Prometheus, which is called Ollie. We did that somewhere in March, but the rest is pretty much the same. I do organize DevOps days, I do organize config management camp, Linux Open Administration days, delivery conf if we manage to get it to Europe, and people still shout at me when they figure out the root cause of their problem was actually DNS. If I go back 13 years, I had this crazy idea together with Patrick to organize a small conference where we invited like 60 to 70 of our friends, and 60 to 70 of our friends coming from these kind of backgrounds. People with over a decade of production open source experience, people with an agile background, and people who were dabbling their feet in the first cloud experiences. And that's where we started doing infrastructure as code, where we're starting to do automation. And if you put all of those things together, we ended up with what DevOps is really about. A global movement to improve the quality of software delivery, leveraging open source technologies, which we started in Ghent in 2009. Now, tomorrow I'm doing another talk, replacing Bram, where I will go deeper into that. But the short summary of what we've been doing over the past decade is this one. We've been running in circles. And that's why with this talk, I want to talk about a number of the patterns I've seen and a number of the things I've seen evolve when we talk about deploying infrastructures. And who still remembers 1996 or earlier when we were doing manual installations? Only Martin. Did anybody use Mondo Rescue to like image? Yeah. Only Dave. Is the goal that I go back to talk to everybody in person? Because who did System Imager? Nobody, okay. So we went from, I have one server to install, and it's going to be a snowflake, and I'm going to craft it really nice to, hey, I want this to be a reproducible one, and then we need to be able to scale this and have, typically back in those days, early 2000s, was like, we need to have high-performance computing setups, we need to have a Beowulf that needs to be deployed. And we started copying images of something that we built once, and we deployed it at another location, which didn't really work, because there was difference in configuration, there was difference in how people wanted to use the thing. And we had kind of identical infrastructures, but we also had image sprawl, because we didn't know where things started from. And then within System Imager, we had this concept of overwrite, where you had a basic image, and on top of that basic image, we added like the changes and the differences that were specific to that node. A couple of years later, Puppet was starting to happen. Things were starting to become really interesting. We had just enough operating system and really early adoption of infrastructure as code. Hannah, if my timeline is off, you had another one. I think it's close to the same. And then early 2010, we were really doing desired state infrastructure as code. And that's where actually the bigger part of these talks is going to be about. And some 5 years later, the cloud started happening. And the differences between all of these stages is that in the early days, we had one server. Then we had more servers. And then we had more servers with virtualization layers. And then the cloud happened, which was basically virtualization layers, but other people's computers. And then containers happened. And the problems we were trying to solve were still the same. We were fighting manual error. Like if somebody needs to configure 10 servers manually, 2 out of those 10 servers are going to have a small change in configuration, which is manual error. People are going to log on to nodes and make manual changes. And it still happens today. I always have to cry when somebody puts up a Slack like devs and ops, and this is what happened in 2010. But reality is, it's 2022, and we're still doing this the same. Most of people's infrastructures were not reproducible. We had human error, and the things were scaling much more. So all of those problems, when we build infrastructure, are still there. I mentioned config drift. Does everybody know what config drift is? I tried to actually make it visual. Like, this is your development environment. It's plain. Nobody touched it. Then you got your acceptance environment, and there's like this one patch on top here, which is a really big and ugly one, and a really small one. And then you go to production, and you see it's actually slightly off. The one patch is still there, but something really wicked happened. And that's what would most production stacks look like. They don't look like what they intended to look like anymore. So that's one of the problems we have to deal with. Image sprawl and golden images. Who still uses golden images? Who thinks they don't use golden images and still uses Docker? Golden images is when you build something, you copy it, you make some changes, you copy them over, you make some more changes, you at some point have no idea how the image that's running got there. Who made it? It's not reproducible. And from a security point of view, it's a nightmare. It's really a nightmare. So what's wrong with this basic code? Yeah, it's not aligned well, but is this reproducible? Is this how you want to deploy Prometheus? If you do this tomorrow, is it going to be the same as yesterday? Nope. There's better ways to do this. If you want to deploy Prometheus, look at the long-term support release that Prometheus just announced that we are maintaining. That's probably something you want. It's going to be a stable release. It's not going to be a random install. So how do we solve this? Well, this solution came close. Matthew has a nice new puppy. It's called Cody. But it's actually infrastructure as code, how we want to do this, which is when we treat our infrastructure as a living thing, we module it, we build code where we actually apply development practices. And we run it through a pipeline as if it would be code. It is code, and we test it. And we put in place a bunch of codes. And it means we want to have reproducible environments. We want to be able to deploy things over and over again because you never deploy something once. There's always that local test environment, that development acceptance, shadow production, disaster recovery. Most of our applications, they're always high available. So you want to keep the configuration between your different platforms in sync. And you really want to have no configuration drift. And if you also do this, you get cheap disaster recovery because you can spin up different platforms. And in 2022, that means we need kind of 3 types of tools. We need tools to do provisioning. And provisioning is where you say, give me an instance of application X, or give me an instance of a container, or a VM, or configure me this from an API. And tools we can use there is things like Terraform, Pulumi. We also still have a large number of VMs running, a large number of services running, where we want to have desired state. I want to be sure that a setup I built today is still going to be the same in 3 weeks from now. And if I spin up a new instance of that setup, it has to be identical. I want to be sure that it is in the state I've defined it is, which means if it's a file, it needs to have those permissions. If it's a service, it needs to be running. If it's a package, it needs to be present. And you want that to be constantly verified. Tools that do this, things like Chef, Puppet, you need something like that in your infrastructure. At least I think so. You can choose not to. And then the third type of thing you need to do is orchestration. This is when you do like non-frequent actions, like, hey, pull me out of the web nodes with an equal version number out of that pool. Or deploy me this application, but only on this set of nodes. Or maybe, well, first do this action on this set of nodes, then do the other action there, and people building runbooks and saying, hey, these, and these actions need to be done to do a migration, to do an upgrade, to do something. And typically, that's where you use tools like Ansible, Salt, Puppet Vault, to do like the one-off thingies. You might need to do those one-off thingies every couple of months, but they're not constantly happening. So those are kind of the three things you want to be able to do. And if we talk about infrastructure as code, there's a couple of things we also need to think about, like things like idempotency. If you run something and you run it again and again and again, do you get the same result or do you get a different result? Like this example, if you run the echo root is disabled to SSH config this way, how many times do you see that line? It might not be a problem for some tool if the config is appended 25,000 times, but for some, well, it's something you want to care about. The other thing you want to care about is a single source of truth, a configuration management database. If you have tools that allow you to frequently run, to frequently set the desired state of your infrastructure, you can actually leverage that and say, hey, I want to take the information I gather from that configuration and populate a single source of truth, which has an up-to-date state of what I have, what is running. You have a fully fledged inventory. And from that inventory, you can actually generate a lot of other things. Typically, the other things people forget when they're doing manual changes, like add monitoring, remove monitoring, add firewall rules, build reverse proxies, create backup configurations, things like that. These are the things you want to think about when you do infrastructure as code. Like there's a list. When you start doing infrastructure as code, or when you've been doing it for 5 years, go over this list of questions. Do you want to achieve this? Do you want to have a reproducible infrastructure? Who does not want to have a reproducible infrastructure? The scary thing is, if you ask some customers of ours, they go like, why? And they do sometimes reply with, no, we don't want any of that. Well, then why are you doing this? And in a way, that's what you need to ask yourself. We've been doing this thingy with tool X, but why? A couple of months ago, I was talking to a customer, and they were doing infrastructure as code, but their actual only goal was to have a number of Ansible playbooks to do patch management. They didn't even try to achieve any of these goals. And for them, it's fine. But when they started thinking about it, well, maybe they could use the tool and do much more with it. So over the past 15 years, we've seen a number of patterns arrive. And they're good patterns and they're bad patterns. And some of them might work for you, and some of them might not work for you. So I'm opinionated. I'm going to have a hard time not showing on my face when I like a pattern or not. But it's not because I have a set of patterns that work that you cannot pick others from this list. So a very frequent one you pump into is, it works for my home directory. There's no source control. And a lot of those cases is like the 2020 variant of a bunch of shell script in some super admin's home directory from where he triggers whatever he does on a daily basis, and nobody else knows how to work it. It's not going to scale. It's not going to help people from collaborating. But show of hands, who still has a bunch of Ansible playbooks in their home directory? We have them. They're there. Because they might not be usable for the other people because it's just what you do. So one step up from that is, well, I've put them in Git, so now it's actually something other people could use and collaborate. So it's a step forward. A pattern we've seen really a lot of time is we just automate the deployment of the operating system and like a number of small services. And everything on top of that, the application, the middleware, it's completely untouched. What do you get when you do that? Well, you get a bunch of partial sources of maybe, because you have these VMs or these services configured, but you don't really know what they're used for. Like, yes, this box has Nginx running, but you have no clue which vhosts are actually running on, which applications are running it. That's some other team's problem, which is one of the root causes of devs and ops fighting. They're in a different silo. And also, when you're doing this, you cannot really build your monitoring platform. You cannot really build all the derived things from that. So Step up from that is we really automate all the things, like operating system, middleware, application. Every single configuration file on a server or in an infrastructure somewhere is managed and monitored. And there's patterns to do so. Very popular pattern, PCS pattern. It's a package, it needs a configuration, it needs service. Service should be on or off. If it's a clustered ecosystem, maybe there's a cluster resource manager who manages the service, but 3 things you need to set up in your infrastructure's code. Package, config, service. One step up from that is package, config, server, but the same code base also adds the non-functional requirements. It configures thresholds for monitoring. It enables or disables monitoring, because maybe some of those services you don't want to have monitored 24/7. It enables backups. It enables external dependencies, like maybe when you spin up a box, you also automatically create a database schema and the permissions to access it on some other resource. And you enable metrics. So that's a step up from that. A variant from that is if you do PCS, you have on the system defined 3 types of files. Something that comes from a package, something that comes from a configuration management framework, and the user-generated data. Now, what do you need to back up? Apart from your Git repositories, only the user-generated data, which makes the whole of your infrastructure so much easier because you can reproduce everything and restore really a small part. Oh, the blue isn't really coming out, but basically it means you have your hardware, you have your operating system managed, your middleware managed, your databases and all the applications level. Then you have some identity you give to the platform, your customer configuration, and everything blue and green is coming out of source control. It's things you can build and reprovision. And you can scale out to different clouds to whatever you want. And only the red part is the thing you need to care about backups for, or also data replication on application level. Make no mistake, data replication, things like replicated databases, that's not backup. You need the backups too. So another pattern we've seen frequently is multiple tools overwriting each other changes. The ops team uses Chef, but the devs have some kind of Java templating tool which they use. And, well, that's how they break things. Or some people are using Terraform, but there's another team who actually uses the UI to make changes. There's no central code base. There's people just running things. Variant of that, the templating tool you use is actually not idempotent. The XML that's generated is actually syntactically correct, but the ordering is different, so every time you run the tool, it changes. Oh yeah, and bonus point, if on a file change, your tool actually restarts the service. So if your tool is not idempotent, how many restarts do you get? Every single time your config runs. Fun debugging that one. Definitely a good pattern I like is your code is checked into a Git repository, and the only way to apply it is by one central user who can do it. Look into that one. Frequent one. So team wrote a lot of code, they used it at deploy time, and then they haven't run it for 6 months. And they don't dare to run it anymore, because it might actually not be in the state they run it. Somebody might have changed things. Somebody might say, yeah. So this might be really good if you're a consultant who goes into a company, sets something up, and then runs away and never have to deal with it anymore. But if you need to keep an infrastructure going and running, this is probably not what you want. Another variant of this is, well, our tool runs, but it's broken, so the people who know how the language works, they left, so we just, yeah, it's like this. Yay, config drift. This is exactly what we wanted to prevent by using infrastructure as code. Yet the number of dashboards which show broken Puppet runs and broken Ansible ecosystems are way too many out there. And then we have the other pattern. We do run it every 20 minutes. We actually check if it's breaking, and when it's breaking, it's an alert equally important as an actual service being down. we prevent config drift, we fix these things, and we actually have desired state. Sometimes, well, people run it in no-op mode anymore because it broke once, and that team who had the impact said, yeah, but don't use this automation. We don't trust automation. Typically, it's a security team. It doesn't trust automation. And now it's turned off. But they have some kind of, they know what the changes are, but it's freaky. And then they have people who have their code base in a CI tool where they check out their Puppet code, they do tests, and look at the scary date, how long people have been doing this. This is not new. Running CI on your Puppet or Chef or whatever code. This is a screenshot I've been using for close to 10 years because that's how long people have been doing this. So this is stackconf, right? So we need to talk about stacks. What is a stack? What is an environment? How do you split those things? Well, we define a set of servers that logically combine a service as a stack, as an environment. And typically, those stacks have multiple ecosystems. They typically exist in a development, an acceptance, a production, a shadow production, disaster recovery flavor. And when you do things like that, you actually limit the blast radius of your code change. Because if in your repository for that stack you make a change, the only thing you're going to break is the first deployment target of that stack. So the worst thing that can happen is you break your development platform for this small group of users. You can use feature flags there. You can actually introduce new variants. And you have a pipeline where you can promote functional and non-functional changes when they are tested, when they actually work. And it's the same code, but it's going to be a different data, different configuration set that identifies which environment is running it. If you're not using the environment, well, your whole code base, if you make one change, boom, that's 3,000 nodes which are going down because that one NTP change where you had a comma missing. It's going to be difficult to scale. Your code base is going to look like role application dev, role application UAT, role application prod, and it's going to have in the code all of those differences. Who has these different roles in their Ansible playbooks? I've seen way too many people do that. Like, why? A variant of that is basically, it's hard-coded in the code. This is how you get config drift. You don't want this. If you are capable of isolating the data, the configuration data, that is split from your code, then you can reuse that code base. You can actually scale out much easier. But it's not what people do by default. Lots of people have the data that defines what a platform looks like embedded in the code. How do you promote changes? How do you move these things forward? So some people have a CI pipeline, but they don't test anything. It's just a deployment framework. So we run the code, we apply it, and we'll see where the errors happen. And it's not really tested. Which is fine if your blast radius is just that first deployment target. But if you have a one-size-fits-all environment and you do just git commit, git push, and then it gets deployed all over the place, then it's going to be problematic. So another pattern we found is a single source of truth. Things like Chef, Puppet, state files in Terraform, where every configuration run, you actually collect the information of the run. You store that information, and you have a central source of truth, updated frequently. And you can reconfigure services based on changes on that data. Your web cluster goes from 4 to 5 nodes, everything gets updated. You're monitoring 5 nodes. It goes from 7 to 2 nodes, well, you clean out the things automatically. Who remembers this picture? Martin is asleep because he does remember this picture. This is Bree's vigorous way explaining how PuppetDBs work. Some node runs some config, exports it to the database. Some other nodes actually collect that information and build on top of that. It's a pattern you can use. If you don't have a single source of truth, I've seen people running Ansible playbooks who did git commits to config files of their not just configuration. Then there were other people modifying that not just configuration. They checked it out, and then I'm saying not just, and then that's why it's because that was really what they were still doing in 2022. And then the other tool checked it out, and that's the config that got deployed. And they called that infrastructure as code. And it was not reproducible, and they were fighting syntax errors in the configuration. It's manual configuration. It's a tool that does it, but it's manual. Come on, let's be honest with this. So your Git repository, what does your Git repository contain? It contains your application code, all of your password, your software binaries. Yes, right? That's how you do it. Another pattern we've found is provisioning from a user interface. Like, people want to have this blueprinting tool where they say, provision me a web server with all of the different variants, being able to fill them in. And they spent ages in designing the different blueprints and the different flavors we're supposed to deploy. And then months later, they realized they cannot actually maintain that incredible list of flavors. The main reason why people start doing this is because they want to have the authentication, the authorization, and the auditing tracks. Well, just put it in Git, and you'll see who modified it, why and when, and let Terraform do the apply, rather than go to the Amazon UI and click away for the VMs you want. People forgetting about open source. Like, what do you mean there's 25 Apache modules on GitHub? We wrote ourselves. It took 3 months to build it. Who's going to maintain it? The guy we just left. Use the open source tools that are out there. Use the community to build on. There's so many tools out there that allow you to just instantly configure what you need and instantly manage things the way you do it. And if you have a new API you want to call to, we started using Zamat for our support frameworks. Guess what? Zamat as an API, we're building a Terraform module to actually configure Zamat. It's open source, it's on GitHub. We expect that other people will eventually do it and use that one. So, one of my favorite ones. People who actually will share and use long-running branches to have the configuration isolated. And they have a branch for development, they have a branch for acceptance, they have a branch for production. And when they need to make a change somewhere, they need to start cherry-picking things, that they have merge conflicts, and they're basically in merge hell. Basically, they've not understood what continuous integration is about. Long-running branches are fucking evil. And if you do not understand, there's great talks out on the internet on why we should not branch stuff. RTNK is an anti-pattern. I've said that ages before. People running GitOps and having multiple kube clusters, multiple environments, and doing a git pull from a branch, same problem. I see what problem they're trying to solve, because on the kube ecosystems, we're definitely not there yet with everything we want to be with infrastructure as code, because we're all YAML engineers now. But branching is not a solution, it's a problem. And then one of the last patterns, because I know Achim is going to start saying that I have 1 minute left, is looking at the industry. For every kind of tool we have, there's going to be people who say, we have a DSL. With that DSL, we can manage 90% of what we need. And for most people, it's going to be 100%. And then there's going to be people who say, yes, but we need more flexibility, and we want you to have a full language where you can do loops and everything you want. And it happened with Puppet versus Chef. And you'll see exactly the same pattern happen again. Actually, it's already happening. At some point, after the Chef fork, well, Adam calls it fork, Puppet Lab said, oh, we're also going to give you that functionality. It appeared. Nobody used it. It disappeared. There's something in the water in Seattle, because Pulumi is doing literally the same with Terraform. Terraform is a good DSL. It covers a shitload of use cases for a large amount of people. But some people say, we want a full language. And Pulumi gives them that, and it's awesome. Terraform is going to have more language support. My question is, how long is that going to stick around? Probably going to disappear because nobody's going to use it. Did anybody remember all of the patterns I just went over? There's probably more, but I only had 25 to 30 minutes. Do I still have time to finish this slide? So my lessons learned is that there's so many patterns out there. There's a bunch of really good ones, but the real question is, which one do you, as an organization, benefit from? Go over this list, find the patterns you like, find the patterns you dislike, and implement the ones you please. But do ask yourself those questions, why are we doing this? Because so many people are just using a tool and not knowing why they're using it anymore. And that is probably the biggest reason why people don't do infrastructure as code with real benefits. So do that exercise. Go over the list, go with your team and say, why are we doing this? Which benefits do we want? And if we want to achieve these benefits, what do we need to change? Which patterns do we need to drop, because they're anti-patterns, and which patterns do we need to approve and implement? And if you only change one of the patterns you're doing right now, then you've learned a hell of things today. Thank you.